Okay, so this is Chapter 1 extra problems that you may have tried. So this is question number 16, which asks you to draw all constitutional isomers. The first one here is C6H14. So I'm going to draw my carbons. So the easiest one is to draw them straight across and fill in your hydrogens. And if I do my math here, I have 14 hydrogens and 6 carbons. So some of you may be tempted to draw an isomer where we have 5 carbons going across, and then maybe putting a carbon here, but this is actually the same thing. So these are the same. And for simplicity's sake, I'm just going to leave the hydrogens off here. So I can draw the 5-chain carbon, but instead of having a carbon branch off of the first carbon, which makes it the same as this one, that's just rotation, I will put a carbon off of the second carbon in the chain. So this is a different molecule than these two. So that would be one isomer. I can draw another isomer with the 5-carbon chain. And now, except I'm going to, instead of putting it on the second carbon, I'll put a carbon on the third carbon. And then you can fill your hydrogens in and make sure that all of your carbons have 4 bonds and all of the hydrogens are in place here. If you were then tempted to draw a carbon chain with 5 across and this carbon on the second one here, these two are the same. But I can do one where I have 4 carbons with 2 carbons coming off this way. I can have 4 carbons with 2 carbons coming off of 2 and 3. And if I tried to do with 3 carbons here and then coming the branching off of that, this one is the same. I have 4 carbons there with 2 coming off of the second carbon, so these two are the same. So that might be all of the isomers for that one. Okay, if we look next at C2h4 Cl, I have 2 carbons. I'll put chlorines on either end, and then H is here. My carbons all have 4 bonds. H has 1 bond and the chlorines have 1 bond. So this would be one isomer. I can either have the chlorines on the same, or I'm sorry, on each carbon, or have them on the same carbon. So those are the 2 possibilities for that one. So that's how you would draw constitutional isomers. And you just want to make sure when you're doing these that you don't accidentally rotate one of these bonds and then think that this is a different isomer. So this second one here, this is not different. Here we're going to identify polar covalent bonds and indicate the direction of the dipole moment. So we're just doing it for water. Water has 2 lone pairs, and that is the direction of the electron density from hydrogen. So this is partial negative. And then the overall net dipole is in this direction where all of the electron density goes towards those lone pairs. For number 19, we draw a Lewis dot structure for each of the following compounds. This is looking at B. I mentioned earlier at some point that the molecules are often written in the order that things are connected. So I have a C bonded to a C bonded to an N. The first C has 3 hydrogens. And I know that carbon needs to make 4 bonds, or has spots available for 4 bonds. Nitrogen has spots for 3, and that's because carbon has 4 valence electrons. Nitrogen has 5. But two of those are in a lone pair. So nitrogen can make 3 bonds, and there's a lone pair left over. So we have 2 spots here that can, or those 2 electrons can get together, and these 2 can get together to form that triple bond in this structure here. And then it's a Lewis structure, a Lewis dot structure, so we don't want to forget the electron lone pair there. Alright, so here we're looking at a Lewis structure for a compound with the molecular formula C4H11N. 3 carbon atoms are bonded to the nitrogen atom. What is the nitrogen atom in the compound? Or what is the geometry? Is there a dipole moment? And then in what direction? So I'm going to look at N. It said 3 carbons. I need 1 more carbon, so I'll just put 1 here. And I need to fill in my hydrogens. Okay, so I have 11 hydrogens, 4 carbons, and 1 nitrogen. This should have a lone pair. So the geometry of this nitrogen is tetrahedral. And it does indicate a molecular dipole. This would be the direction of the dipole arrow. Where these are partially negative. I'm sorry, positive. Partially positive. And so your overall net dipole is in this direction. So we're looking to determine if these have a net dipole. Ammonia does. That would be in this direction. CO2 is bonded to 2 oxygens. And this does not have one. And that is because these oxygens are pulling in opposite directions. CCl4 has individual dipoles, but no net. In this question, we're looking at 5 constitutional isomers with the formula C2h4 Cl. Indicate any dipole moments for each of these isomers. So you can just start filling things in to see if we can make them fit here. I get 6 hydrogens. So here I have already 6 hydrogens and I have O3. So I'm missing 1 oxygen. So I have 2 carbons, and one of these carbons has 2 OHs, the other one has 1. I can draw an isomer where all the OHs are on the same carbon. We can draw a structure where the oxygen's in the middle. So that would be 3 of them. There is another one. And there is another isomer. So all of the oxygens in each of these constitutional isomers have 2 bonds. Hydrogen's making 1 bond and carbon is making 4 bonds. And then we're looking at dipoles. This one, the dipole would be in this kind of downward direction. Here it is in this direction. This one has no dipole, no net dipole. This one would go in this direction, and that one goes in this direction as well. Which of these compounds will exhibit hydrogen bonding? So the ones that will hydrogen bond, so I'm going to draw the molecules out first. So I get 2 H's, a C, and an O. And carbon's is only making 3 bonds, oxygen's making 1, so I'm going to put a double bond here. This one can hydrogen bond at this part. But not to itself. If it was in an aqueous solution, such as in water, it could hydrogen bond to that, but not to itself. C2h4. We get a double bond there. There is no hydrogen bonding. Those H's are on carbons, and they need to be on N, O, or F. For CH3 and H2, we have carbon with 3 H's that's bonded to nitrogen, which itself has 2 H's, and a lone pair. This one can hydrogen bond at the NH. Okay, Ambien is a sedative used for the treatment of insomnia. It was discovered in 1982 and brought to the market in 92 because FDA takes a long time to approve drugs. So we're looking at hybridization and geometry of each of these atoms, of each carbon atom. I'm going to use blue dots to indicate sp2. So any carbon that has a double bond is sp2. That includes carbon-carbon bonds, carbon-nitrogen, or carbon to oxygen. I think I got all of those. And I'm going to use a red triangle for sp3. There are no triple bonds here, so I don't have to worry about sp. So anywhere carbon is making 4 bonds, that is my sp3. I believe that is all of those. So the sp2 hybridized are trigonal planar, and sp3 are tetrahedral. Okay, there are 2 compounds with the molecular formula C2h6. One of them has a much higher boiling point than the other. Explain why. I will draw 2 isomers. So this is C2H6O. That would be 1 isomer. This one will have the higher boiling point because there is hydrogen bonding possible. This one has no hydrogen bonding. It can hydrogen bond to other protic solvents or solvents that have hydrogen bonds in them, but it cannot hydrogen bond to itself. The last one here, we're going to look at the 3 compounds and answer the questions. One correction here, this should be a C. It's a C triple bond N. So letter A is asking which 2 compounds are constitutional isomers. Remember that a constitutional isomer has the same formula, but it's connected differently. If I look at the formula for A, I have C4H9N. This one is C4H9N. This one has C4H7N. So A and B are constitutional isomers. Which compound contains a nitrogen atom with trigonal pyramidal geometry? The nitrogen that is singly bonded will be the trigonal pyramidal one, so this one is B. The one with the greatest number of sigma bonds, let's check those out. This one has 13. This one has 14. That one has 11. So that would be B. The one with the fewest sigma bonds would be C. The one that has more than one pi bond is C because there's a triple bond there. Which compound has an sp2 hybridized carbon? That would be A. Which compound has only sp3 hybridized atoms? This would be B. And the one with the highest boiling point is the one that is capable of the most hydrogen bonds, which would be A. B does not have H's on the nitrogen, so that can't hydrogen bond. And then C has a nitrile, that carbon triple bond nitrogen, but there's no hydrogens there, so that cannot hydrogen bond either.